Refresh my display. I just woke up, so yeah, that's that. Okay. Okay, perfect. Let me just check where I stopped on Sunday. Okay, got some weird gradient going. FPS is looking steady at 29. Ah, yeah, I do remember. And oh yeah, cam will go up. Weird things happen when it moves. Alright, anyway. Then we can go ahead for now. Zoom this in.
Involved in the complete sort of software stack of a game all the way down to the hardware, which I think is actually really important and is becoming a little bit more of a lost art these days. So this project's kind of an attempt to bring that back, to basically have everything there from start to finish, so anyone who wants to really study how games work through the entire pipeline, through the entire code base, have the opportunity to do so. And I think it's really great too, just in general, for everyone to kind of be aware of this sort of stuff. I know it certainly makes it much easier for me to do any kind of work that I'm doing on games, whether it happens to be using libraries or happens to be using engines or not, because you can always go in there and fix stuff. You can debug so much more effectively. You can know when something is suspicious, just when you have sort of that kind of full background. So that's what we're doing here, and we have basically finished sort of our prototyping layer. We made a Win32 layer the past couple weeks so that we can basically do all of our own stuff right on top of Windows without having to use any libraries or anything. And it's pretty basic at this point. It does basic sound output and basic bitmap output, and also it does basic input from user devices like keyboards and gamepads, and that's really everything that we need to get a game up and running. So that's exactly what we're going to start doing here. But I felt like we had done a bunch of the hard work of like picking through Windows and like dealing with all of its APIs to do stuff, and really we were just doing that in order to get sound output, bitmap output, and input into the thing. And so what I thought would be nice to do tonight is to do something fun with the Windows API to kind of show like, okay, when you're down there and you're doing crazy stuff, you can actually do some cool things if you've done all of this yourself. And so what I wanted to show is kind of like an example of something pretty cool you can do, and it's going to be an example of sort of something very useful to a game developer. So if you are following along at home here on day 21, if you have purchased the source code using this handy dandy pre-order button here on handmadehero.org, you will get a link in your email that should have allowed you to basically, there's a link that comes when you pre-order the game, and that will always allow you to download the source code. So save that link, go there, and there should be a day 20 zip file inside the source code zip. If you unzip that one, that is the source code we're starting with. So look for day 20, because every day we start with the previous day's source code. So if you unzip that into a directory, you will have exactly the same source code that I am starting with now, so you can follow along at home, which I know a lot of people like to do. So let's go ahead in there, and we have some stuff. We have a few issues that I have in my notebook that I want to address from previous days, but right now I'm just going to go ahead and do this. We'll get to them in the Q&A. So I'm going to go ahead and jump right into like new stuff, sort of the fun stuff that I want to do. So, all right. So basically, one of the things that people often ask me, in fact, they asked me this multiple times on the sort of about Handmade Hero. They basically say like, are you going to implement a scripting language? This is asked. This has been asked many times. Or more specifically, I suppose, are you going to use a scripting language? And the answer is no, of course, we're not going to use a scripting language. But the question of whether or not we were going to build a scripting language, well, that would still be making something from scratch. So we could decide to build our own scripting language if we want to. But we have to ask ourselves the question, is building a scripting language really all that great of an idea, right? And in order to know whether it's a great idea or not, you have to kind of stop and ask yourself, what do you think you're going to use this scripting language for? And is it going to provide more benefits to you versus the downsides that a scripting language has? And of course, scripting languages have a lot of downsides that maybe people don't realize right away, one of which is performance problems. Because remember, if you implement a scripting language, you are also on the hook for ensuring that that scripting language is performant, which may mean that you have to use just-in-time compilation or all these other sorts of things in order, if a significant amount of your game is written in the scripting language, you're on the hook for that performance, and that's something you have to be aware of, right? It's not like C, where you know how to optimize it and you've already got tools to profile it and all these, and an optimizing compiler there to back you up. It's not like that when you're using a scripting language, you're on your own, right? And similarly with scripting languages, you have to ask yourself, what are you going to do about debugging? Do you have a debugger for the scripting language? Are you going to write one yourself? Are you going to use some third-party one? And will that integrate properly with the debugger for the platform that you're using? Or are you going to have to constantly ping-pong back and forth between debuggers? There's all sorts of things that could go wrong. And so when you're talking about implementing a scripting language, there's a huge number of costs that go with it. And
I'm not sure why people implement scripting language. Why do games use scripting languages? Two schools of thought. Scripting language is powerful, full-featured. Large portions of game code are written in the language, and code is moved to C++. Performance dictates that it's necessary. Scripting language is extremely limited. Almost all game code is in C++. Still don't know why it's used. Rapid prototyping, flexibility, and customization. Can be exposed to players, allowing them to create and share their own modifications and custom content. I'm still not sure.
so you have to be very aware of those costs. Now, that doesn't necessarily mean that you shouldn't do it, but it does mean you have to think very hard about whether or not it's a good decision. For Handmade Hero, since we're doing everything from scratch, I think it's kind of a no-brainer that it would be a bad decision, because we're certainly not going to want to take the time to write a debugger for the scripting language and an optimizer for the scripting language, a compiler from the scripting language, blah, 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 blah. All the things we would have to do a really good job of using the scripting language in a game, we're not going to do those things, because that would take a huge amount of time out of learning the stuff we want to learn, which is more about how to write the game code. And so given that that's the case, I would then say, well, okay, what are the reasons why people might want a scripting language? Like, what is a scripting language good for? Why or do they even think they need it? And can we just go ahead and get those benefits without having to do all of the work, right? So I think one of the primary benefits of a scripting language is that people perceive it to be easier to write things in a scripting language. I don't really know necessarily where that comes from so much, because I think it's actually pretty easy to write things in C if you make the API to it correct. So I don't think we're going to have too much trouble writing our game code in C. I think we're probably going to be fine with that. But one of the other things that people often point to in scripting languages that's a benefit is the fact that we can do things like edit the scripting language while the game is running. Now, this is a pretty big bonus in a lot of cases, because if you can edit the scripting language while the game is running, you can tune variables live on the fly. You don't have to try to, exit, recompile, go back into the game, that sort of thing. And you can also do stuff like, well, if you're trying to debug the behavior of a boss monster, you can just go in there, when you get to the boss monster and see that it's not working, you can just right there pop up the script, start editing it, see what the boss monster does, and change it and all that stuff. And it saves you from having to make a whole bunch of scaffolding to allow you to exit the game, change some boss monster code, jump back into the game, jump straight to the boss monster, actually deal with the stuff there, see how it went, go, oh, okay, it didn't work, jump back out, blah, blah, blah. So there's kind of a lot of stuff there where it's like that ability to just use, to edit the code right in the middle of the game is pretty valuable, actually. That's a pretty big thing. And so there is something you can do there, right? You can, inside Dev Studio, right? If I open up Dev Studio, there's a thing called Edit and Continue, right? Which allows you to edit stuff inside Dev Studio. You can set a breakpoint, you can edit some stuff, and you can have it recompile. And that works for some very limited cases. Unfortunately, a lot of the time, edit and continue doesn't really work. If you're writing tons of new functions, and if you're actually trying to really write new code, edit and continue doesn't work. It's usually for small changes is the only thing that it's really reliable for. Otherwise, it mostly just breaks. So edit and continue isn't really a good solution, but it's sort of like what we would want, right? What we'd like to be able to do is just kind of go all right, the game's running and we have the C code. We want to just be able to edit the C code and have the game just keep on running, right? So the question is, well, could we basically implement our own version of edit and continue, right? Is there some way that we could go ahead and do that where we actually don't have to worry, we basically don't have to care about Visual C++ and whether it can do whatever it's supposed to be doing with its compilation step? Could we actually make it so that we have what amounts to our own sort of relatively foolproof edit and continue? And so what I'm going to do tonight is I'm basically going to try to implement that. I'm going to try to implement a way where we can basically have our game running, change the code live, and not have to restart the game to see the results, and just basically let us kind of go from there. And we'll see how far we can get towards that goal, basically. And I think that's kind of fun, so I said tonight's kind of time to do something fun, rather than spending all our time doing stuff just to get...
That does sound like fun. How do you... Alright. Let's have a look first.
Windows sort of as a conduit working. Let's see if we can actually use Windows to help us now to make something pretty cool. So the first thing that I want to do is go, all right, well, what I know about the way that I've set up the game, because I think I've architected it pretty well, is basically I've got this sort of platform independent part here, right? That's going to hold all of the game code. It's going to hold that stuff that I want to be able to edit on the fly. And then I've got a Win32 portion, which is separate. So the first thing that I'm going to want to do is I'm going to say, well, could I just split those two things apart so that we basically have one part that's the platform code that's compiled separately, and one part that is the platform non-step code that's compiled separately. And then maybe, just merge them together. And, can I do that in some way that doesn't force us to unload, to kill the executable? And you've already basically seen the answer to this question is yes, right? Because you've already seen that we have a thing here, which is basically the load library. I don't know if you remember when we were talking about this kind of a while back.
Oh, yeah.
We have the ability to load code out of a library already dynamically, right? We can basically pass a file name that's one of these DLL things, right? That's something that Windows has implemented. We can load that in. We can call getProcAddress on it, right? And getProcAddress will give us a pointer to a function that's in there, and then we can just call the function, right? So if we want to do that...
Interesting. I never looked into load library. I do remember that. Now we gotta Google it. Load library equivalent SIG. Windows only. Proc address. That's like to get the function. Let me ask Cloud. Is there a zig equivalent to load library? Understand. Oh yeah, I do remember this. Standard dot. Plus some dynamic library loading and symbol lookup. Okay, so I could, for instance, pulse audio could be loaded dynamically. All right, okay.
We could just do that with our own code. So there's really no reason why I couldn't, instead of compiling this monolithically as one translation unit, I just compile it as two separate translation units, one for the platform code, one for the platform independent code, right? And that platform independent piece of code, I then just load as if it's a DLL. I call into it to do whatever it is I need it to do. And then when I want to refresh it, if I feel like it needs to be reloaded, I can just close it. I can just free library, which is the corresponding call to load library. I can just free that library and reload the new freshly compiled code, and I don't have to kill my executable, right? I mean, it should just work. So the reason that this is simple is because, as you know, we're basically passing in the game memory as a chunk. Now, I've said a couple of times that there's a lot of good reasons to do this. Well, this is a big one of them. Since we're passing in all of the game memory, the game itself is not the actual game code is never actually doing anything with memory. So if we just hold on to that game memory which we've allocated, we pass it to the DLL when it needs to run, we can unload that DLL and we still have all the memory. So if we then reload another DLL that's a new version of the game code, we can just call into that and pass it the same exact memory that the previous DLL was using, and poof, it'll just go ahead and keep running in there. Now there's a couple caveats of times when it doesn't allow you to do that because of depending on what you change in the C++ code. But for now, that's a pretty easy way to envision a very simple way to make this work. So what I'm going to do here is I'm just going to change our build.bat a very, very tiny amount, right? Basically, instead of compiling this 64-bit line, instead of compiling it this way, I'm actually going to compile two different things. I'm going to compile the handmade.cpp. I'm going to compile that, and I'm going to compile the win32 handmade.cpp exactly like that. So basically what happens here is inside this, where we have this sort of stuff here, right? I'm effectively going to start to bifurcate these two code paths, right? I'm going to go ahead and take into handmadehero.h. I'm going to go ahead and pull the things that we actually had pound-defined out here, right? I'm going to pull those into here like this. So that now I've basically got, oops, I should keep that at the top. So now that I've kind of got those out there, this guy is still going to look at handmade.h, right? Like this. This guy's still going to have to look at that. It's going to need to see a couple of these things, right? But now it's no longer going to include this handmade.cpp anymore. That's not going to happen. So instead, handmade.cpp is only going to happen inside actual handmade.cpp. So it's going to be compiled separately. We're not going to like pound include the CPP file into Win32 handmade, right? Does that make sense? So then all I need to do in my build.bat, and there's a couple other things we're going to have to do here, but basically all I have to do in my handmade here.bat is figure out, my build.bat I should say, is I have to figure out what to pass to this CL thing to build one of these DLLs, one of those DLLs that we were loading before. Basically, the compiler has the ability to build DLLs as well as link with them and so on, like we were doing where we were linking with import libraries and doing stuff like that. It has the ability to build DLLs itself, so what I really want to do is just make it so that I can build that DLL as well. And so what I have to do there is, I think it's a pretty straightforward switch, actually. I believe it's just a DLL switch to the linker. It's been a long time since I passed it, but I'm pretty sure there's almost nothing to it. It's like, yeah, it's just that /DLL. I believe that's pretty much almost the entirety of all we're going to have to do. So /DLL there, I think is all we're going to have to do. And I don't think we're really going to have to do anything else. We don't actually even need most of those other libs there, because really, in fact, we don't really need any of this stuff. None of these common linker flags are actually relevant to us. I think all we actually need is the /DLL. So let's go ahead and take a look at what that does first, just so I can see what's going on here. All right, these guys are no longer internal. Obviously, these are actual linkage calls. We'll have to deal with that in a second here. Let's see here. So we got to get rid of that because they're actually going to be exported. This is the first time we'll ever have an exported function. Let's take a look. We've got, those are not, yes, right. These are the calls. These are our calls back into it. Let's see here. Dgo platform read entire file. So these are no longer internal either. Those are going to be like that. And there we go. All right. So now I think, besides having our unresolved externals, I think we're in pretty good shape here. Let's take a look at our errors in Win32 handmade as well.
Oh, I see if I can get to that part. I do remember in build.zig. Oh, I don't remember. Where's the import? Handmade.zig. What about the methods? I'm only using the types. Oh yeah, that makes sense. Oh, does it? Yeah. So I've got to make it available during build time. Yeah, I think I should probably read this a little bit. Simple executable. Installing build artifacts. User provided options, standard, conditional compilation. Static library, dynamic library. Sounds good. All the files same from static library example, except build.zig file is changed. Okay. I think there is a add library. No. It needs an executable at the end. Can I take multiple? Take single artifact. What is B? Okay, some package. I think I'd go to do it somewhere here. Module. Let's just try add. Can I add it to exe dot compile? Compile dot root module dot add library path. Okay, so exe dot module was it? Add library. Hang on, actually it just needs to be, I don't need to install artifact. It just needs to build. Dot linkage is going to be dot dynamic. Version doesn't matter. And then root module. Dot create. Target and optimize target. Okay, now what do I do with this lib? As in the static library example, to make an executable link against it, use code like this. C dot link library. Set it zig build. Okay, it's just missing the zig out. How do I know if it's the build worked? Now I gotta load. Comparisons of external symbol pointers, so we don't need this helper function. Okay, thank you. That is just a regular mustache. Like map. Wonder how can I? It's already linked. Dude, build. lib handmade debug native. Okay, so it is. Well, if there's an example. Zig to C, C to zig. Looking for. Might have to remove these globals. What's a link map iterator? What's this? Alright, let's just give it a go. What is this return? Slice of pointers to that. Get dynamic. All caps. Okay, so I'm gonna have to move these in here and this here. Let's see if I can find an example. So technically, the library should be linked to the executable. Let's have a look at the static library. Static library from zip code and also an executable from other zip code that consumes it. For function fizzbuzz. Okay, so which is the root file? Demo.zig. Interesting. So I guess I could do undo this. So instead of handmade, extend struct. Okay, I can only link functions. Is there external type? Excuse me. Let's have a look at the doc. Yeah, here. External union. What's this? Creates a reference to an external symbol in the output object file. Interesting. Creates symbol in the output object file, which refers to the target of pointer. Is that the only documentation on it? Construct has memory layout matching CABI for the target. Yes, cloud. Can you show me an example? Loading library dynamically. I've linked the lib to the executable urine build. Okay, is that it really? Made is, what is import? Okay, and just regular import. Oh, you check the OS tag? Interesting. Okay. If built-in.os.tag. Is that it? What if I just ignore Windows for now? Const handmade. Okay, just need the lib name. Handmade Hero. Is that what I've named it? Takes apart. I guess since it's already linked, should be. Let's find out. Catch unreachable for now. Or maybe I can just print the error. Okay, what do I do next? Okay, you gotta close the lib. Load a function from the library. Can I load a struct from the library? The linked lib is also in the as a reference to the function. Yeah, no, I can do that. Okay, so you gotta sort of redefine the struct. Mhm. Okay, I think I get it. Get some coffee. Mhm. Does it even need to be defined there? Well, it kind of does, because hang on. Did the other headers just... Oh, okay, interesting. I can inline this, so I don't need this. I think I can do the same for here. But I don't need a method for write audio. External struct. Okay, because I don't need, I don't think I need all of the values. What does write audio need? Get buffer size. I can get rid of that method. All I really need is the buffer. Okay, yeah, I think I can simplify this. To be slice of I16. Into cast, and this would be sound dot len. Okay, but I think for the window, I need a bit more. That could work. Okay, I think off-screen buffer, I can leave it as is. All I need is window width, height, and the memory. You don't need the pitch. I wonder if that's enough. I'm not sure. Some buffer dot. Oh, let's see what happens. Dynamic library. Did it not save? No. Fine. Just use any. Okay. No field named some buffer instructs. Is it exported? It's public. I think you gotta call lookup. Change the type. Method lookup. What do I set on the sum buffer? I just leave it empty. Do the same for here. What am I to win? It up. Expected type pointed to dynamic library. Expected point type found main.sound buffer. Let's have a look at here. Look up what does it do? I think it's ELF. Is it? I'm not sure. Let's just try the first one. Pointer from int symbol. Oh, I didn't know you could use if this way. Interesting. Look up address by name. Interesting. So what if I no field names, sound buffer, and dynamic library? Why did that fail? I do miss the debugger at this point. Would have been nice. That worked. Enable to resolve comp time value. Oh, it's optional. I think it's, or else unreachable. Types must be comp time known. Alright, let's look for a second how Casey does it, because I wonder if that is defined.
We were expecting linker errors that we're going to deal with those in a second. I'll explain how to deal with those in a second, but I just want to take a look at these. Let's see here. We've got, right.
Define local function, external symbol.
These are no longer internal. These are called externally. Although that's not really true. Well, we'll see in a second what we do with those. Those are probably premature. All right. So basically, all I did was I just split the code into two compilation units. And as you can see, there's basically places where they called each other: game update and render and game set get sound samples, and then the debug read free file memory, write entire file, and read entire file. These are basically the places where our two halves of our code called each other. And so as you can see, now that we're compiling them separately, we just get a bunch of linker errors that tell us, you know, I can't resolve this stuff anymore. You're calling stuff that doesn't exist in the translation unit. I don't know where to find it, and that's an error. So what we have to do is figure out ways to resolve these. Now, the two where the platform layer calls the game, I just said how we can do that. That's really straightforward for us to resolve. We're going to treat it just like we treated X input, where we're going to load library and do that kind of stuff. You can see here where we basically have sort of these get proc addresses, this sort of stuff. That's all we really need to do. So really all we need to do here is basically do something where we go win32 load game code or something like this. And all we're going to do with that is we're just going to do that load library, and we'll call this handmade.dll for now. We can obviously play with that a little bit later. Handmade code, or we can just call this game code, or game code DLL. If that actually works, then we will try.
Realize there's another way to do it. If I moved what if I move these to like a common file? What do I use? Sample rate and tone hertz. What I can do is I can just pass it this sine C. But it needs the buffer. Or I just return it the buffer. How can I do this in a way where I don't need to know about sound buffer, the type, and instead just add this. That would make it a lot more simpler. I mean, it could be loaded dynamically. Alright, let me get rid of these. What is the error then? Yep, no field name sum buffer. Just a sec.
When I'm
I do need to know number of channels, sample rate. But these don't really need to be here, do they? Well, they kinda do, because they dictate how big the buffer's gonna be. I know there's a better way to do it, but I don't know exactly what that is. Forgot about the input, totally. There must be a better way without having to like redefine the struct. I was thinking was having like a common .sig and then just defining the types here. Let's try it. Took all of these. Instead of having these. Okay, it's no longer handmade dot. Okay, that should just work now. Do I need to look up the function? Maybe not. Handmade. Okay, there we go. So not sure how that will work during build, but that's a problem for later. And then I need game render equals handmade dot lookup. going to be a pointer to a function. What else do we need? Type and name. Game update and render. Void. What did I call it? Call it game code. I think it's optional. Yeah. So it needs to take game memory, keyboard input, off-screen buffer, and some buffer. Does it need to take? I can just look up here. Memory input, off-screen buffer, sound buffer. Let's see what happens now. Game memory. This is just input. Expected type commented off-screen buffer found pointer. What do you mean? Should be a pointer. 218. Oh, I forgot about that. Expected type by 16 pound comments on buffer. Yep, I know. Yeah. Right, audio is gonna be pointed to comment.sound buffer. Fail to load. Oh, okay, I forgot that I changed the name. I set it back. Fail to load handmade lib file not found. It is out. There is no extension. So I don't know. Just leave it as is. Why does it fail? I don't know why that failed. Error file not found. This does expect a part. Extend specifier is used to declare a function that will be resolved at link time. when linking statically, or at runtime when linking dynamically. Try that. Function. Library didn't fail before. Let me go back to build. Change that back. Then file not found. The quoted identifier after the extern keyword specifies the library that has the function. libc.so. I don't think that's it. It's more for like C code. So close. File not found. Where's the build? Here, static library. It's already linked, so I'm guessing you can just, let me try that. Instead of all this malarkey, get rid of that. Yeah, get rid of it. I think that's more for like C code. Date and renderer. Game memory. And then common dot some buffer. Turns nothing. Right, I don't need that as well. Undefined symbol, game update and render. Okay. I don't know if that's better. Okay, so everything is same except the build. Extern function, fizz bars. It should just work really. It doesn't seem like it wants to. Let me check if there's no typo. Memory input buffer not buffer. Blah. lib handmade underscore lib.so. I can see that it's linked. Okay. It's not very readable. What does one do in this situation? Is it public? I think it is because I was using it before. Yep. There is no export, right? Oops, sorry. Say go. Oh, what? That's so cool. Let's go. That's awesome. I just loaded the dynamic. Nice. Okay, what do we gotta do next, Casey? What do we do with this?
To do get proc addresses on it, and those get proc address calls will give us the pointers to those exported functions that we wanted. So basically, we're in here. You can see we've got game update and render and game get sound samples. All I'm going to do now is do the exact same trick we did for X input. It's going to be literally exactly the same. It's this exact stuff right here. Nothing else to it. So all I'm going to do is basically say there is a game update and render, and that takes a name, and it is exactly this function prototype that we had here before. So I'm just going to go ahead and make that like this. Then I will make a type def for it, just like I did before, and this will be called game update and render, and then I will make a stub for it.
Okay, this is what I need to see.
If we wanted to, we can make it so that we can just reload that code on demand, essentially, right? So if we want to, we can say, okay, this is Win32 load code. We could also do something like this, Win32 unload game code, right? which would basically be taking this Win32 game code thing here, and it will take one of these and unload it, just flat out get rid of it, right? So we've got our game code. It's going to take a pointer to the game code, and it's going to go ahead and say, if it's valid, right? Well, actually, I guess it doesn't even need to do that. It's just going to go ahead and do a free library on game code DLL, right? Assuming that game code DLL was actually DLL. There we go. Assuming that it was actually there, it's going to free it.
Okay, so that means... So I gotta load it this way, so I can... Here. I can open it, and then close it, and then open it again. Okay, so open is the same as load library, and free library is close. Guess I can comment this out. And it's not really the cleanest of code, but kind of works, so... That's what it was called. Well, I can just do an unreachable. Add a defer for now. Dot no, that's not it. Need to look up. needs type. It's pointed to a function that takes Is that it? And the name. Okay. What did I call it? Game code. Okay, not bad. Segmentation for all to that was 0. Game memory, the game state dot tone hertz is 256. Is this not a pointer? Yeah, it is. Not able to load. Why is that not modifiable? Primary input off screen buffer, sound buffer. Guessing the variable names are not part of the pointer function. It might be, I'm not sure. Not sure.
And then regardless of what it's going to do, it'll just go ahead and set this stuff so that basically the game code is no longer considered valid, right? It's not valid anymore. And everything is reset to the stubs. Game code, update and render. Game code, set sound samples, that. And so that'll unload our game code, right? So let's see. No object file generated. Unload game code unreferenced local function. Okay. Well, that's fine because we're about to use it. So now, if we really wanted to be absurd, which I don't want to be, but I'm just going to demonstrate the fact that we could be absurd if we wanted to, in theory. We could go ahead and actually just load and unload the game code every time through this loop, right? There's absolutely no reason why we couldn't do that, right? I can go in here and I can say, all right, I'm going to take this game code and I'm going to load and I'm going to unload it every time, right? So there's the load. Oops. Sporadic key class. There's the load. There's the unload. So what I'll do is I'll go into our running thing. At the top of the loop, I'll load the game code in. And after we're done with our game loop, I'll just unload it, right? Which one of these? Let's see here. That's while global running. So there we go. And that's the samples. So in theory, I think that'll actually work, but it'd probably tank our frame rate. But I think it actually would work. Let's find out. Yeah, so it's going to ruin things a bit for us. But, you know, it appears to work. And you can actually see it if you actually look in here. If we look at our history, you can see us unload and load, unload and load, unload and load all the time.
What I think is happening is because memory is defined in a separate SIG process. I had the same problem when I was trying to use Pulse Audio. I couldn't update memory. Pulse Audio couldn't update the memory, which was passed by SIG. Let me check something. Can I load and unload dynamically linked? Import. Yeah, but I want to know why. No. Sig. Fault. Bad memory. Dangling pointer zone. Use after free. Invalid memory access. I mean, there is a workaround. Do is pub function init game memory. Did I call it? I don't know why I thought that would work. I guess I'll have the same problem when I try to update the buffer. Do that here. Interesting. So is it not the same memory? That should have been initialized. Yeah. Okay, at least the window loads. I'll figure that out tomorrow. Alright, I think that should be it. Gotta go to work soon. I need that. What else should I close? Yeah, this was quite useful. Running system tools. Generating Zig source code. Yeah, I think this one I've already seen. Alright, okay. I think I'll figure the rest out tomorrow. That was actually quite interesting, even though I didn't fully get it to work. It's old. Okay, yeah, I'll continue here tomorrow. I mean, the next one looks very interesting too. Instantaneous live code editing. That sounds fun. Alright, thank you for hanging out, as always. I shall see you back here tomorrow. Hope you have a good day. See ya.